Hello everyone, this is Infinity Vision and my name is Rehan Nawaz. This is the fifth lecture on ratio. In previous two lectures, we began our problem solving session. So we'll continue with the same. As you know, whenever you encounter any mathematical problem, you should always begin by reading the question properly, because once you read the question properly, you understand the demand of the question. And when you have the demand of the question, you would be able to extract all the relevant information. And the art of connecting these two is nothing but the art of problem solving, which we are going to explore further in this session. Let's look at this problem, that is practice problem 16. The question reads, show that the eliminant of ax plus cy plus bz equals 0, cx plus by plus az equals 0, bx plus ay plus cz equals 0 is a cube plus b cube plus c cube minus 3abc. So what you need to understand, that if I look into these equations are nothing but linear equation, and you have three variables. And as you know, in our theory sections, we discuss these type of equations and how to handle them. So what we are going to do, we are going to take care of these two equations first. And from these two equations, we are going to write the proportion of x, y, z. Once we are able to write the proportion of x, y, z by cross multiplication method, we can write our x, y, z in terms of lambda. Once we have x in terms of lambda, y in terms of lambda, z in terms of lambda, I can replace x, y, z in this equation. Now the first equation would be totally converted in ABC and in terms of lambda. And then since on the first equation you see ax, cy, bz, and on the right side you see 0. So lambda would be coming common, and that could be easily eliminated, and the eliminant would be the one which we have to prove. So let's begin by finding the proportion of x, y, z using these two equations. For that, you know, you have to begin by cross multiplication method, that is x upon y upon z upon. Now you know, when you are trying to write x, y, z in what proportion, you have to understand that you have to write the equation in a right order, in which the first term would be x, the second term would be y, and the third term would be z. And the second equation should also be written in the same order, bx plus ay plus cz equals 0. Now when you have written your x, y, z, the constant which you have to write below x, you have to hide this two terms, and then you have to see what constants you have. You have b here and c here. So you multiply b into c, that is going to be bc, and you multiply this is going to be bc minus a square. Now when you are going to write the constant below y, you're going to hide y here. You're going to see you have a, you have c, you have c, you have b. So a will go with b, so you're going to write ab, and c would go with c, so you're going to write minus c square. And for the constant below z, you are just going to hide these two terms, and then you're going to say c into a is ac minus b square, so you're going to write ca minus b square. Now you can write everything is equivalent to lambda, because you have the continued equal ratio. So what you can say, that x is nothing but lambda into bc minus a square, y is nothing but lambda into ab minus c square, and z is nothing but lambda into ca minus b square. Now what we can do, we have successfully written our x, y, z in terms of lambda. I'm just going to replace it in this equation. Now the first equation has first term as ax, so after a, I'm just going to write x ke badle I'm going to write lambda into bc minus a square, plus cy, in place of y I'm going to write lambda into ab minus c square, plus bz, in place of z I'm going to write lambda into CA minus B square equals to 0. Now what I can see that I see lambda here, I see lambda here, I see lambda here, lambda being common, I'll just take out lambda out. It would be A will multiply with BC minus A into A square, that would be A cube. Then C with AB, that would be ABC minus C into minus C square, that would be minus C cube. Then B into CA, that is going to be ABC, and then minus B cube equals to 0. Now what you can do, lambda can easily be taken out because on the right hand side you have 0. So you got the expression as 3ABC because you have ABC, 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 and then you have minus A cube plus B cube plus C cube equals to 0. So if you rearrange it, it would be A cube plus B cube plus C cube minus 3ABC equals to 0. And that is what the eliminant we have to prove. So it was a pretty easy question. What you needed to know, you just needed to know that whenever you encounter 3 linear equations and 3 variables in this form, you are just going to write your xyz in terms of their proportionality, and once you have found out the proportionality, you would be writing xyz in terms of some constant which you can put it here, and then you can get rid of that part, and then you would be able to get your eliminant in ABC, which is the constant given in your original question. Let's solve this problem. That is practice problem 17. The question reads, eliminate x, y, z from the equations ax plus hy plus gz equals 0, hx plus by plus fz equals 0, and gx plus fy plus cz equals 0. Now, the question is somehow exactly the same. In the previous question, they gave us the eliminant. In this question, we have to find the eliminant. For that, we'll be going with the same approach. We'll be using these 2 linear equations to find the proportionality of xyz. Once we know the proportionality of xyz, we'll be writing xyz in terms of lambda, and then I'll be putting my xyz in this equation. I'll get rid of my lambda, and then whatever the constants I have, that would be my eliminant. So let's begin. So I'm just going to write in the right order. The first term is going to be hx, the second term is going to be by, and the third term is going to be fz equals 0. And the second equation is gx plus fy plus cz equals to 0. As you know, you have to understand, you have to begin with bf, then fc, then hg, and then you have to end with bf. This is how we write the constant for below our variable xyz, below x, below y, below z. Now you know this is going to be bc minus f square. So I'm just going to write bc minus f square, fg minus ch. So I'm going to write fg minus ch, hf minus bg, hf minus bg, and I can say everything is equivalent to lambda. So what we can do, we can write our x is nothing but lambda into bc minus f square, our y is nothing but lambda into fg minus ch, and our z is nothing but lambda into hf minus bg. Now what we are going to do, we are going to replace xyz from here using these 3 equations. So now this equation would become a into, for x I am going to write lambda into bc minus f square plus h into, for y I am going to write lambda into fg minus ch, and for gz, for z I am going to write lambda into hf minus bg, and the whole thing is equivalent to 0. As you know, lambda lambda. Lambda is common, so lambda would be out. And inside I'll get a into bc, that is abc minus af square, the first term. Then hfg or fgh minus ch square. And for third, we will get fgh minus bg square equals to 0. So you can say your eliminant is nothing but ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. So you have been able to eliminate your XYZ, and your eliminant is going to be this expression, that is ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. Let's look at our next problem, that is practice problem 18. The question reads, if x equals cy plus bz, y equals az plus cx, and z equals bx plus ay, you have to show that x square upon 1 minus a square equals y square upon 1 minus b square equals z square upon 1 minus c square. Now if you notice, again the question is somehow the same. You have three variables and all the three equations are linear equations. So first thing what I can do, I can simply write them in a right order, means each equation beginning with x, then y, then z. So the first equation would look like minus x plus cy plus bz equals 0. I just transported my x to the right. The second equation would become cx, y would be coming on the right, minus y, and then plus az. And your third equation would look something like bx plus ay minus z equals 0. Now when you see, you have three equations, and the thing you see that you have x square here, y square here, and z square here. So what we can do, we can use these two equations first to exactly find at what proportion x, y, z are. So if I use these two equations, I can write x upon y upon z upon. Now for x, I'll just hide my first two terms. So c will go with a, that is ac, minus of minus b, because minus 1 into b is minus b, so that is going to be plus b. For y, we are just going to hide our second term, so b will go with c, bc, and minus of a into minus 1, that is going to be a. And for the last term, we are just going to hide our z, minus 1 into minus 1 is 1 minus c square. So this is the first relation. Somehow we got, okay, 1 minus c square here. So it means that we are on a right track. Let's look at these two. So I'll just write x upon, I'll just hide the terms for x. So minus 1 into minus 1 is going to be plus 1 and minus a square. Okay. So here we have x square upon 1 minus a square. So we just got x upon 1 minus a square is equal to y upon is equal to z upon. For y, we are just going to hide the y term. A is going to be with b, ab, minus of minus c, that is going to be plus c. And for z, we are just going to write ac, because a into c is ac, minus of minus b, that is plus b. Now what about the first and the third? So we are just going to focus here, the first and the third. So if I focus in these two, I would be able to write x upon y upon z upon. For x, I'll just hide the first two terms. So c will go with minus 1. So minus c minus AB. So I'll just write minus C plus AB. And for y, I'm just going to hide this y. So b will go with b, that is b square minus of minus 1 into minus 1, that is plus 1. So b square minus 1, so I can write minus of 1 minus b square. If you notice, we got b into b, that is b square minus 1. So instead of writing b square minus 1, I wrote minus of 1 minus b square just to handle the negative sign. And for the last z, I'm just going to hide these two. Minus 1 would go with minus 1 would go with a, that is minus a, and then minus bc. So minus will again come out, a plus bc. Now what we can do? We can simply get rid of my minus. Now first thing I need is x square upon 1 minus a square. So I see here x into 1 minus a square. So I will simply multiply with these two. So if I multiply these two and then I multiply these two, can I say both of them are both the products are going to be equal? Of course, because this is equal to this and this is equal to this. So if I multiply these two and these two, they would be equal. So what I'll get x into x, that is x square upon 1 minus a square into ac plus b. What is making me think in this direction? Because that's the intuition, because we need to have x square upon 1 minus a square. In the same fashion, we need z square upon 1 minus c square. So this is also complementing us. So z into z would become z square upon 1 minus c square into ac plus b. Now if you notice, this AC plus B and this AC plus B is common, so we can simply eliminate them, and I can say x square upon 1 minus a square is equivalent to z square upon 1 minus c square. That's one part of the equation we have to prove. Now what about the second part? What we are going to do? We are going to handle this equations with this equation, let's say. So I can say x into x is going to be x square and c plus ab into 1 minus a square. So I got c plus ab into 1 minus a square. Since I need my y square guy, so I'll use this y into 1 minus b square into y into ab plus c, that is going to be y square into 1 minus b square into ab plus c. Again, I see c plus ab and I see ab plus c. So these two can be cancelled and I can say x square upon 1 minus a square equals y square upon 1 minus b square. So you have x square upon 1 minus square equals to z square upon 1 minus c square, and x square upon 1 minus square equals to y square upon 1 minus b square. So by transitivity, we can say all the three are equivalent. So it was a easy problem had you understood the intuition of the problem and how to handle the symmetry and in a very structured way. Let's read our next problem, that is practice problem 19. Again on the same line. Given that a into y plus z equals x, b into z plus x equals y, and c into x plus y equals z, show that bc plus ca plus ab plus 2abc equals 1. Now you have three equations, three variables, and all the three linear equations in the same form, ax plus by plus cz form equals to 0. And then you have to prove that BC plus CA plus AB plus 2ABC equals to 1. So in this expression, you don't see XYZ. So in other way, they are asking you simply to eliminate XYZ, right? So what you're going to do? You're just going to try to write first in a right order. So I'll be using first these two equations. And when I'll be using these two equations, I'll be writing them in a right order. So what I can write, BX minus Y plus bz equals to 0, And if I look here, I can write Cx plus Cy minus Z equals 0. Now using these two equations, what I can do, I can write my x, y, z in what proportion they are. So for x, I can hide my x. Minus 1 into minus 1 is 1 minus bc. For y, I'm just going to hide this. B into c is bc minus of minus b, that is bc plus b. Let's cross check. B into c is bc and minus 1 into b is minus b. So bc minus minus b is going to be bc plus b. And for z, I'm going to write bc. B into c is bc and minus of minus c, that is going to be bc plus c. Now what I can write this is equivalent to lambda. Let me just write it properly. Now I can say x is lambda into 1 minus bc, y is lambda into b into 1 plus c, and your z is lambda into c into 1 plus b. Now what we have to do, we simply have to write these x, y, z here in the first equation. So my first equation would become a into y plus z. So for y, I can write lambda b into 1 plus c. And for z, I am going to write lambda into c into 1 plus b. And this whole thing would be equal to x. And what is my x? My x is lambda into 1 minus bc. Now what we can do, we simply see that lambda and lambda would come out and this lambda would cancel this. So I can simply cancel these lambda and I can say a into b plus bc, c plus bc is equal to 1 minus bc. In the same way, if I I will put a inside the bracket, it would become ab plus abc plus ac plus abc 1 minus bc. So what we can do, we can simply see that we have, if I bring here, minus bc would become bc, ac would become plus ca, then ab, then twice of abc equals to 1. That is what we had to prove, or basically this is going to be the eliminant. So it was a very easy problem. We have been doing a lot of eliminant problems in the previous 3 questions. So something it's very easy. I'm sure you would be able to handle it. Let's see this problem, that is practice problem 20. You have to solve the following equations. 3x minus 4y plus 7z equals 0 and 2x minus y minus 2z equals 0 and 3x cube minus y cube plus z cube is equal to 18. So now you see 2 linear equations and 3 unknowns, and the third being the cubic equations, but they all are pretty symmetric. Now these 2 linear equations suggest me that I can somehow find the proportionality of x, y, z. Once I understand the proportionality of x, y, z, I can write x, y, z in terms of lambda, and then I can reduce the third cubic equation in terms of lambda, and then I would be able to find the value of lambda, and once we have the value of lambda, we would be able to write the value of x, y, z. A simple approach, a similar approach. Let's solve this. Already they are in a right order, so simply I can write x upon y upon z upon. For x, simply I'm just going to hide this. Minus 4 into minus 2 is 8 and minus 1 into minus 7 is plus minus 7, so minus minus plus 7. For y, I'm going to hide y, so 7 will go with 2, that is 14, and minus 2 into 3 is minus 6, so minus minus plus 6. And for the last guy, I'm just going to hide my z. 3 into minus 1 is minus 3. And 2 into minus 4 is minus 8, minus minus plus 8. So now what I can do, instead of 8 plus 7, I can simply write 15. So I'll just write 15 here. Instead of 14 plus 6, I can write 20. So I'll just write 20 here. And for 8 minus 3, I'm just going to write plus 5. So that would be a simple one. And then I can say they all are equal to lambda. So I can say my x is 15 lambda, my y is 20 lambda, and my z is 5 lambda. Or rather, we can further simplify it, because this is 5 1, 5 4, and 5 3. So instead of writing 15, I'll just write for z, I'm just going to write lambda. For y, I'm going to write 4 lambda. And for x, I'm going to write 3 lambda. I'll just replace x, y, z in this equation. So 3 into x cube, that is going to be 3 lambda whole cube, minus y cube. Y is nothing but 4 lambda. So I'm going to write 4 lambda cube. And z is nothing but lambda. So I'm going to write lambda cube equals 18. So this is like 27 lambda cube into 3, that is 81 lambda cube. And this is minus 64 lambda cube. And this is plus lambda cube equals 18. Now what we can do, we can say 81 plus 1 is 82, minus 64 is 18 lambda cube, which is equal to 18. So I can say lambda cube is 1. Now, you know, this can be written as lambda cube minus 1 equals 0, which can be written as lambda minus 1 into lambda square plus lambda plus 1. How did we write it? Because we know what exactly a cube minus b cube is. That is a minus b into a square plus ab plus b square. Now you know this quadratic expression will have no real roots, because the discriminant is going to be negative. So the only root you have is lambda is equal to 1. Now when you have lambda is equal to 1, you can simply say that your x is 3, your y is 4, and your z is 1. An easy problem. You just had to follow the same procedure which we have been seeing in the last 4-5 problems. Let's look at this problem, that is practice problem 21. You have to solve the following equations. X plus y equals z, 3x minus 2y plus 17, z equals 0, and x cube plus 3y cube plus 2z cube equals 167. Exactly the same problem. You just need to write this equation in a right order. X plus y minus z equals 0. And then you are going to write x upon y upon z upon. For x, you're just going to hide your x. So you'll get 1 into 17, that is 17. And minus 2 into minus 1 is plus 2. So you're going to write minus 2. And for y, you're just going to hide your y. So minus 1 would go with 3. That makes it minus 3. And then 17 would go with 1. That is minus 17. And for z, what you can do, you can simply say 1 would go with minus 2, that is minus 2, and 1 would go with 3, that is minus 3, equals to lambda. So you got x upon 15 equals y upon minus 20 equals z upon minus 5 equals lambda. Again, you can say 5 3s are minus 4 and minus 1. So you can say your x is nothing but 3 lambda, your y is minus 4 lambda, and your z is minus lambda. I'm just going to replace it. So x cube would become 3 lambda whole cube. Your y cube would become minus 4 lambda cube. And your z cube become minus lambda whole cube equals 167. So this would become 27 lambda cube. This would become minus 64 lambda cube into 3, that is minus 192 lambda cube. And this would become minus 2 lambda cube is equal to 167. Now 27 minus 194 is nothing but minus 167 lambda cube is equal to 167. So you can say lambda cube is equal to minus 1, or you can say lambda cube plus 1 equals 0. Now how to handle this? You know what is a cube plus b cube? That is a plus b into a square minus ab plus b square. So this can be written as lambda plus 1 into lambda square minus lambda plus 1 equals 0. Now, how do you solve this quadratic equation? You won't be able to solve in a real terms because the discriminant is negative. So when the discriminant is negative, you don't have the real roots. So you can say that lambda is equal to minus 1. Once you know that lambda is minus 1, you can say your x is minus 3, your y is plus 4, and your z is plus 1. This is going to be your answer. Exactly the same problem which we did in the previous question.